Welcome to my algebra class. We're on chapter 4, section 2. We're beginning the work with polynomials, describing what they are. A monomial, mon means one, has exactly one term, and that would be like the numbers, just numbers by themselves, which we call constants, 8, or a y, or a 3xy. In other words, they don't have any addition, subtraction signs. So a constant, a monomial is just a number, no variable. Bi means two. Binomials have two terms. Here's an example, 3x and 2y. They're separated by an addition sign, two terms. And here's another one, 4 minus 3x, separated by two terms. By the way, this is your vocabulary. You could be copying it down in your notebook. A trinomial has three terms. Tri meaning three. So this is a three-term polynomial. 3x is the first term, 2y is the second, and 7 is the third, and they're separated by addition and subtraction signs. Polynomial is any expression that has more than one term, so a binomial and a trinomial would be a polynomial, and you can have 4, 5, 6, 7 terms, etc. The coefficient of a term is the number that's in front of the variable. For example, 3xy, the coefficient is 3. If I have mn, the 1 in algebra or math is very seldom written down. The coefficient is understood to be 1. If I have a negative AB, the coefficient is negative 1. You can pause and finish copying these. The rest of your vocabulary, you have to remember what like terms are. They're terms that have the same variable part, like 3x and 5x, and that allows me to add them together and get 8x. Now the following, I'm going to do some examples other than the ones that are here. The degree of a variable in a monomial is the exponent of the variable. So in this example here, 3x squared y to the third, the degree of x is 2 and the degree of y is 3. Down here, in this example, the degree of the variable x equals 3 and the degree of the variable y equals 2. And the degree of z is understood to be 1. So each variable has a degree. Then you have the whole monomial. This is a monomial. There's no addition signs. So the degree of the monomial is the sum of all the degrees of the variables. So in this problem right here, in our vocabulary, I would add 2 plus 2 plus 3 and get 7. The degree of x is 4, y is 1, and z is 1, so that's a degree of 6. Here in this example, 3 plus 2 plus 1, the exponents, gives the degree of the monomial, and that would be 6. Second example, the degrees for the variables are 5, y is 1, and z is 1, so the degree of the monomial is 7. And then finally, you put these monomials together and get polynomials. The degree of the polynomial is the greatest of the degrees of its terms after you simplify. So this polynomial is simplified. There's no way you can add anything together. The degree of this monomial is 3 plus 1 or 4. The degree of this monomial is 5 plus 2 plus 1, which is 8. And the degree of this one is 1 plus 1 plus 1, which is 3. So it's the largest degree of the individual monomial, so the degree of the polynomial is 8. Now we're going to be adding and subtracting polynomials, and I'll use this example here. So I can add like terms. I can ignore the parentheses since there's nothing in front except plus sign. So I have an x cubed y and I have an x cubed y. I add the coefficients. That's 11, x cubed y. Here's an xy squared, here's an xy squared. I add the coefficients. A positive 5 and a negative 6 make negative 1, or negative xy squared. Then I have a y cubed and a y cubed. Coefficients are negative 3 and negative 4, so it's negative 7y cubed. And then the constant, negative 5 and a positive 9 gives me slide this back where it belongs, a positive 4. Negative 5 plus 9 is positive 4. So there's my sum. When you subtract polynomials, remember subtraction, you change it to addition and you do the opposite of everything after it. So this needs to be rewritten as 2x cubed y plus 5x y squared. Nothing happens to this since this is the number I'm subtracting from. Now here I do the opposite of everything here. So this is negative 9x cubed y. The opposite of negative 6 is plus 6xy squared. The opposite of a negative 4 is plus 4y cubed. And the opposite of positive 9 is negative 9. Now, add like terms. Here's x cubed y. It's a 2 and a negative 9 make negative 7x cubed y. Here's an xy squared. Here's another xy squared. Coefficients are positive 5 and positive 6. That makes positive 11xy squared. Now I have y cubed. Y cubed, coefficients are negative 3 and positive 4. That makes 1 y cubed. I'm not putting the 1 down. And last, my constants, negative 5 and negative 9 make negative 14. We're ready for the assignment, so get your papers out and your books open. And we're on page 148. Papers headed, folded, and we're starting with the oral exercises 1 through 16. Problem number 2, name the similar monomials. We'll copy the monomials down, and we'll just use different groupings of lines. Okay, we'll put one line underneath this. Is there another st squared? Yes, there's one right here, so these are like terms. Now move to the next one. This is s squared t, and this is also s squared t. So we're just going to use lines, different groupings of lines to indicate the like terms. Number 4, copy the problem down. So we have an xy squared here, and we have another one. So those are like terms. We have an x squared term and an x squared term, and those are like terms. There is no y squared term, so we're done. Problem number 6. In exercises 5 to 10, first part is state the degree of each variable, and then the degree of the monomial. So there's 2 parts to these. Number 6 is 7ab cubed c. So part A, the degree of each variable. So A is 1, B is 3, and C has an exponent of 1. Remember, degrees are exponents. Part B, the degree of the monomial, you add those up. 1 plus 3 plus 1, the degree is 5. Problem number 8, the monomial is negative 3a to the 5th b c squared. Part A, the degree of each variable, the exponents. A has an exponent or degree of 5, B has an exponent of 1 or degree of 1, and C has an exponent of 2 or a degree of 2. In part B, the degree of the whole monomial, add the individual exponents together, and we have a degree of 8. Problem number 10, the monomial is negative 2u to the 4th, b to the 6th, w to the 2nd. Part A, the degree of each variable, or the exponent u is 4, b is 6, and w is 2. And then the degree of the monomial, add the individual exponents together, and the degree is 12. (11 through 16) state the degree of each polynomial, and if it is a binomial or a trinomial, say so. So number 12, we have negative 2x squared minus 4x cubed plus 6x minus 5. First, we need to find the degree of each of the monomials. This one is 2, this is 3, this is 1, and this is 0, since there is no variable. So the highest degree is 3, and that's the degree of the polynomial. This is not a trinomial. It has 4 terms, nor a binomial. 14, we have p squared q cubed minus 3p q to the 4th. The degree of this monomial, add the exponents, is 5. The degree of this monomial is also 5. So the largest degree is 5. That's the degree of the polynomial. And it has 2 terms, so we can identify it as a binomial. And 16, 2s squared t plus 3s t squared minus s squared t squared. The degree of the first monomial, 2 plus 1, is 3. The degree of the second monomial, 1 plus 2, is 3. And the third one is 2 plus 2, or 4. So the degree of the polynomial is the largest of the 3 of them, which is 4. And it has 3 terms, so this is a trinomial. Now we're doing the odds for the written exercises 1 through 51. So I'm going to do 1, you'll do 3, I'll do 5, and so on. So number 1 on page 148, copy each polynomial and underline similar terms, as we did in the oral exercises. So number 1, copy it down, 3x minus 2y minus x minus 3y. There's the x term, here's another one, so single line under that. Here's the next term, and its like term is 3y. Okay, you're going to do 3, I'm doing 5. So 5, copy it down, a squared plus 3ab minus 4ab plus 3a squared, underlining like terms. One line under that, one line under that, they're both a squared. We have an AB term, and we have another AB term, 2 lines. You're doing 7, I'm doing 9. The directions are to add these polynomials. These are done vertically, and we can also do them horizontally, so we're just going to do what the book asks us to do. Normally I do them horizontally. So we have these 2 binomials, add them. 5y plus 2y is 7y, and negative 3 plus 9 is positive 6. 11, 3y plus 8, excuse me, I gotta go up more. I should be doing the next one. So number 13, we have 2r minus 3x plus 5 added to the trinomial negative r plus 3x minus 2. 2, take away 1r is r. Negative 3x and a positive 3x, adding the coefficients, we get 0. Those are gone. 5 minus 2 is plus 3, so our answer is r plus 3. 17, we have 4x squared minus 3xy minus 5y squared. And to that we're adding 2x squared plus xy minus 3y squared. Notice how they lined up like terms. Adding just the coefficients, we get 6x squared. A negative 3 plus a 1 is negative 2xy. A negative 5 and a negative 3 is negative 8y squared. Number 21. For 21 through 30, we go back to exercises 9 through 18, and we subtract the lower polynomial from the top one. So number 21 is actually number 11. So we have 3y plus 8. Might help you put the number by it so you don't get lost in it. 3y plus 8 and 2y minus 5. Now we're subtracting, which means we change the signs of the second polynomial. Don't forget that. Now we can add 3y minus 2y is just y. Hang on a second, I gotta make sure I got the right one. I don't think I do. Okay, so number 21 would be go back to number 9, sorry. Number 21 is 9. And 9 was 5y minus 3 and 2y plus 9. And we're subtracting, so we change the signs. So 5y minus 2y is 3y. A negative 3 and a negative 9 is negative 12. Remember, subtraction changes everything after it. So now I'm doing 25, which would be number 13. So 13 was 2r minus 3x plus 5 minus r plus 3x minus 2. So we're going to subtract the second polynomial from the first, so we change the signs of the second one. Two r plus r is 3r. A negative 3x and a negative 3x is negative 6x. And 5 plus 2 is 7, positive 7. Number 29 is number 17. So we have 4x squared minus 3xy minus 5y squared. And the second polynomial is 2x squared plus xy minus 3y squared. Now we're subtracting the second one, so we need to change their signs. That's negative 2, negative xy, and positive 3y squared. Adding 4x squared, take away 2x squared is 2x squared. Remember, you work only with the numbers. Negative 3 minus, that's understood to be a 1, so that'd be negative 4xy. A negative 5 and a positive 3 is negative 2y squared. Okay, the next problem is 33. And they want us to simplify. The problem is 2x minus 5 in parentheses minus the quantity x minus 2. Now these are done horizontally. So there's nothing in front of the parentheses, so I can just rewrite it as 2x minus 5. This is subtraction, so I change the signs of everything after it, so that's minus x plus 2. Adding like terms, 2x minus x is x. A negative 5 and a positive 2 is minus 3. (37) I have 3n squared plus 5n minus 6 plus quantity negative n squared minus 3n plus 3. This is an addition problem, so I can ignore the parentheses. 3n squared minus n squared is 2n squared. Positive 5n and a negative 3n is positive 2n. And a negative 6 and a positive 3 is negative 3. Just watch your signs. It's what's in front of the variable. 41. You have u cubed minus 3u squared v plus 2u v squared. And we're adding that to 3u squared v minus 2uv squared minus v cubed. Again, since what's in front of the parentheses is either nothing or the addition sign, I can ignore the parentheses. I have a u cubed and there is no other u cubed, so that's it, bring it down. I have a negative 3u squared v and a positive 3u squared v, so those go out. I have a positive 2uv squared and a negative 2uv squared, those go out. And then I have the minus v cubed, and that's all I have. 45, these are equations that we solve applying what we've learned about polynomials, adding or subtracting them. So this is 7x minus the quantity 3x minus 2. And remember, subtraction changes the signs of everything after it, or you take the opposite. So 7x minus 3x plus 2. Change the signs. The next step is always to collect like terms, simplify, so I get 4x, 7x minus 3x is 4x plus 2. Checking both sides, there's nothing I can simplify. So I begin transforming, subtract the 2. I get 4x equals 8. Divide by 2, by 4, and I get the answer, which is 2. (47). Oops, let's go back a minute. That was 40. The last one was 45, so I should be doing 49. So 49, we have 4y minus 3, and this is a subtraction problem, so this is going to be different. Minus quantity 4 minus y equals 3 times the quantity y plus 3. So there is nothing in front of the parentheses here, so I can just bring down the 4y minus 3 and drop the parentheses. This says to subtract this, so that changes everything inside, so that's negative 4 plus y. Using my distributive property, getting rid of parentheses to simplify, that's 3y plus 9. Now I simplify. I can't stress that enough, that you simplify until you can't do anything else before you transform. So the 4y and the y make 5y. The negative 3 and the negative 4 make negative 7. Now there's nothing else I can do. The next step is to get the variable on one side. You're not transforming yet until you get the variable on one side. So I subtracted 3y, now I have 2y minus 7 equals 9. There's no variable anywhere else except one side. No more simplifying, now I can transform. Add 7. I get 2y equals 16, divide by 2, and y equals 8. That concludes the evens. Check the answers as you do each odd, ask for help, and please remember you simplify first everything that you can possibly do. Get the variable on one side, and after that, and only after that, do you begin the transformations.